now. Great. So let's start now. All right. All right. So last time when we left with few questions. All right. So let me pick those questions if you have some time. Okay. All right. All right. So we have session 2. All right. So whose questions should I look at? Has somebody done the subjective questions? So basically, before, okay, Abhinav has done it, and all right. So here are few things. Okay. All right. So before we start the session now, let me just go through a streaming job. Okay. So Mega has also done it. Great. Great. Excellent. Now, in today's session, we are going to first discuss something about streaming job, and then we will discuss problems, the problems where we left off in the last session, and then we'll talk about further details about MapReduce. Okay, great. Now, here is the first one. So first of all, Hadoop streaming job is the easiest way to call Hadoop. Okay, the easiest way to do the MapReduce because it takes lesser time to write few commands than compile and edit the Java code. All right, so we'll start with the streaming job. How do exactly we do the streaming job? Okay, so here is a syntax. Here's a syntax. Let me just copy to the notepad and then we will. Okay, so what exactly is a streaming job? A streaming job is a library in Java from Hadoop which makes it possible to use any command as mapper and any command as reducer. That is the role of streaming job. All right. Now here let's have a look at, is the font visible enough here? Okay. Okay, or we could just put a slashes at the end of. Slashes is to quote the to comment out the new line. Okay, so let me just go through the syntax here. This is Hadoop is the command line which helps you interact with MapReduce as well as HDFS. It has got the first argument saying that we want to execute our jar. Jar is the bundle of code from a compiled bundle of code, just like you have exe in Windows. Similarly, in case of Java, you have jar file. All right, and this is the jar that contains the MapReduce library, MapReduce code, which essentially makes it possible to use any command as mapper and any command as reducer. Okay, it takes 4 arguments. Okay, so Sushant's question is, does it mean that any application wanting to uh, interact with Hadoop needs to execute this streaming job? So it's not on application, it's us who wants to get MapReduce done quickly on some data set. For example, all the 4 problems which we talked earlier is done this way. All right. Okay. So here, now what does it say? The first one we say this Hadoop jar my jar. Then it expects these kind of arguments. Our jar contains an entry point, and that one is basically expecting 4 arguments. These 4 arguments are given to our code. I mean this Hadoop streaming code dot jar, whatever is there inside it. It expects 4 arguments. First one is the input folder, then output folder. So from here, all the files which are lying in this folder, it will read from there. We can also specify the name of the file here instead of saying folder. In that case, it will read only one file. Okay. Now here it's output folder. This is where the output of reducer go in the HDFS. Both folders are from HDFS. And then our command that we want to use as mapper. This is the command which is going to break down the input into key and value pairs. Okay, and this is the command which is going to break down the key and value pairs into key and multiple values into single value. Okay, that's what it is going to do. Or this is going to handle the sorted keys. Okay, we'll talk about it again when with an example, proper example. So here we go. So these are minor differences from what we discussed last time, right? Here, when the reducer is being called, it is not given key and multiple values. Instead, it is given key value in a sorted manner. Okay, so the values, it's up to this command, this reducer, to convert it into values. Okay, into uh, aggregate the values for a key. That is the role of the reducer. That is the little bit. Okay, so the let me answer Seema's question. The output is copied to HDFS again. Is it distributed again, or is it? No, it is distributed again. Okay, I'll show you how to read from there. In streaming jobs, that's Abhinav's question. In streaming jobs for input files, we have to provide path in local machine, or so it has to be in HDFS. So both these folders have to be in HDFS. All right. This is HDFS. This is HDFS. Okay. Let me before we start, I'll just say for I in 1 to 4, 1, 2, 3, 4, do echo root root at Hadoop $I dot no big data dot com shutdown minus R now. Actually, I'm trying to reboot these services. Can you please tell me command to see path of the file, like when we import file to HDFS, in which location will be stored in our cloud labs. Okay, so do you mean to say the physical location where is it stored? Yeah. So basically, okay, let it reboot. I've actually rebooted it for some time. Okay. Okay. So all right. So here, if you see, we go to. All right. So it is somewhere here. Let me just have a look at our Hadoop. Let it finish rebooting and then we'll have a look. All right. What is the password uh, to SSH this for student? Swati, I have mentioned it in the co. If you go to my courses and under this here, if you go to session number 1, there is an installation instruction. You can have a look at it there. Okay. Here there is installation instruction, because I cannot tell it because this video might be shared with other people who may not have access to the cloud labs directly. Okay, now the all services are down, so give me a second. I'm going to turn off the video for a second. Okay, I'll have to turn off the video for a second. All right, so let me just restart all the services. Good. Let it restart. Now, all right, let me get back to the track. All right. So, yeah. So, Abhinav, your question is still pending. Let it come up and it'll show you. All right. Now, let me get back to what is streaming job, and then we'll discuss more questions which we left, and then we'll have further discussions into details of MapReduce. Good. Now, there is a little bit difference in the way streaming job works. The only difference actually is the input to the reducer. The input to the reducer is not key an array of values. Instead, it is the sorted keys. That's the only difference. Now, here, this command, how many of you know what does this command do? What does SED do in Linux or Unix? Replace. Good. Anybody else? Good. Good. Right. So basically, this command, if you look at this command, what does it do? It basically replaces spaces with new line. It will replace each space with new line. Okay. That means that instead of having multiple words in a line, it will become single word in a line. Okay. Although there are faults, but we'll not get into uh, here. It could be made better, but we'll make it better in steps. Now, once this output comes in, when it replaces the space with a new line, the input, the text becomes like this. Okay, one word per line. This dashed line here shows that what does Hadoop do with the output of your mapper. This is this is what your mapper does. So this is the output. This is the output of your mapper, and Hadoop takes this output of your mapper and starts sorting it. So in case of a streaming job, it basically sorts it. It basically sorts it, and it does not bring all the keys. Convert all the values for a key together. Instead, it just sorts the keys such that the same keys are nearby. Okay, same keys are adjacent to each other. All right, as you can see, Sasa has come together here. Okay, now the job of your reducer here is our command unique minus C. If you guys know a little bit about unique command in Unix, what it does is whatever input is given to unique, it basically converts it into the frequency of each word. Unique minus C counts the number of times a unique word has appeared in the text. And it only works if it basically considers each lines and tries to compare it. The other part is unique only works if your input data is already sorted. If the input data is not already ordered or sorted, it doesn't work properly. Okay. So as you can see, I will show you this. Okay. Here, if I do echo sa, all right. Now it looks like this. If I do unique minus C, so because the data was not sorted, there was S, A, then S, right? Therefore, unique did not give a proper answer. Therefore, unique expects the input data to be already sorted. Okay. Now, as you can see here that and that's when, because unique it does not do any churning, it just goes from top to bottom, and it keeps on going from top to bottom and keeps on counting, increasing the count till the point it finds the same word again and again. And the moment it stops finding the same word, it finds a new one, then it prints out the uh, word and then moves to the next word. It does a simple job. It goes from top, it founds ga, then re. So the moment it founds a different word, it say one ga, then it moves to the next word and then says, okay, sa is different than re, and therefore it prints one re, and then keeps on moving and then say, sa has come up twice sequentially, and therefore it prints. So basically, unique only works if the data is already sorted. Now, how does it look when we talk about multiple reducers? The logic is same. Okay, the same keys will go on to the same reducer. Okay, it would never happen that a particular key exists on multiple reducer. Okay, so Sasa will a particular key will always be on a particular reducer. That's all. Okay. Now, so let me try to run it if our cluster is up. Okay. Let me try to run it if our cluster is up. What is it going on? Says data node up, but these are not started. Okay, so I think it only started the HDFS, but not yarn. All right, now let's have a look at what's going on. So basically, just before the class started, I shut down the cluster. Okay, okay, so streaming is really slow. All right. Do you want me to connect again? So my Wi-Fi is correct. So let me try to connect it again. Maybe this time it works well. All right, let me